Hello everyone. Today we'll discuss about what is a fault and how to identify a fault in a field. So fault is a fracture surface along which the blocks from either side has moved. So here we can see the fault where the blocks are moving along the faults. So there are three types of faults like the normal fault, reverse fault, and strike slip fault. And the development of the fault is linked with the three different mechanisms. Those are the compression, tension, and the shear. Compression, when the compression occur, the both the blocks moving towards each other. As a result, the reverse fault is developed, in which the hanging wall but let me clear what is a hanging wall and the footwall. So hanging wall is a block which is lie above the surface above the fault plane, and the footwall is the block that lie below the fault surface. When the hanging wall moved up over the footwall along the fault plane, that is called a reverse fault. But when the hanging wall move down relative to the footwall along the fault surface, that is called as normal fault. And the normal fault happen because of the tension when the rocks pull apart away from each other at a particular plane, and the reverse fault happen because of the compression where the rock pull towards each other. And the strike slip fault happen during the time of the shearing. So the rocks move horizontally with respect to each other, so this is called the strike slip fault. Here is the real world example of a fault where we can see the footwall is here and the hanging wall is in the opposite side, and this is the example of the San Andreas fault, which is a major strike slip fault located in the California, United States of America. So why faults are important? Because the faults are actually always linked with the earthquakes, and they controls the formation of the mountain, valley, and basin. There are many mineral deposits are also associated with the fault because the fault act as a conduct for the movement of the fluid along it and has capability to deposit different types of the mineral. Let's learn about how to identify the fault. So here in the first number one diagram, so here we can see the block which are moving and offset from each other. So the offset one is the first criteria. So we have to look in the field here. Is there any offset in the horizontal strata, particularly in the sedimentary or the foliated rocks? And the second criteria is the fault plane. The fault plane. This is the fault plane, as here you can see the mark, and the either side of the fault plane has different orientation. So this could be uniformity, so it should be carefully checked. And here it is saying that the altitude of the either side of the fault plane should be different. So in the fault feature, what are the different features which are generally associated with the fault plane? The first one is the fault breccia. In the fault breccia, the breccia is the angular fragments of the rocks which has developed during the time of the faulting, because the fault is brittle in nature. So when the fault develops, the rock fragments are closed and those are developed along the or close to the fault plane. And the second thing is the fault gouge. Fault gouge means a very fine, crushed, and clear rich fine material developed along the fault plane. Third point is the fracture rocks. And these are the fracture rocks which are developed near the fault, which are highly crushed, and intense fracturing is obviously seen. And the quartz and calcite vein. The quartz calcite veins are developed and close to the fault because after the faulting, and the hydrothermal fluid that pass through the fault and fracture, and the quartz and calcite veins are developed. And the alteration is also common phenomena since the fault allow the fluid to migrate along the path. So silicification, ferruginization, and corrosion like alterations are commonly developed. So other features like the omission and repetition of the strata are also taken as the example or evidence of the faulting. And site which is developed about the fault surface also indicates the direction of the fault. So it is also one of the criteria to identify the fault.